I was thinking about the structure of the observer, and then suddenly someone kind of gives me a hint, not directly, but by asking a leading question. And why does this Mobius strip keep catching our eye? Is the Mobius strip an infinity symbol? Is the Mobius strip a number 8? It is easy to guess that the structure of the observer is somehow connected to the Mobius strip, and then it is quite transparently hinted that if we pay attention to the similarity between the infinity symbol and the number 8 with the Mobius strip, we might learn something about this structure. But if we think about this hint, we will quickly realize that there is too little information. It is clear that the resemblance of such symbols to the Mobius strip suggests that they are somehow connected to the Mobius strip. But there is no more specific information about what this connection is. It's not a fiasco at all. It's just time for our main fundamental assumption to appear. We assume that the author of this hint, through the similarity of the infinity symbol and the number 8 with the Mobius strip, wants to tell us that not only the infinity symbol, but all mathematical signs are somehow connected to the Mobius strip, or not just the number 8, but all digits, or all numbers, might somehow be connected to the Mobius strip. Agree, this is a more interesting hypothesis. Here at least there is an opportunity for various coordinations, but there are a lot of mathematical signs. They are very different and not arranged in any sequence. This means they can be combined for a very, very long time. In my opinion, this doesn't quite seem like a solvable problem. The numbers are arranged in a sequence, but this sequence is infinite. It's clear that I can't handle infinity either. The numbers remain, especially since the author of the hint explicitly mentioned it. The infinity symbol, maybe by the number 8 he meant exactly the symbol, the digit 8. So here is our final formulated main hypothesis. We assume that the author of this hint made the number 8 resemble a Mobius strip to suggest to us that all numbers, not just the number 8, are somehow connected to the Mobius strip. That all numbers are involved in this puzzle. All the numbers we use every day are specifically designed for this hint puzzle. Yes, in a way it's a spectacular assumption, but it will be all the more interesting if it suddenly gets confirmed. So how can numbers be connected to the Mobius strip? And what do we use numbers for? And numbers are meant to be written on something, so let's write them on the Mobius strip. Let's write, as usual, from left to right, approximately vertically, and so that no numbers are in a special position, evenly, at equal distances from each other, across the entire surface of the Mobius strip. As a result, we ended up with this structure, and at the same time, the moment of truth arrived. If our hypothesis is correct, we should see something interesting now. As you can see, the numbers are arranged in pairs opposite each other. And imagine we already see something interesting. We have already received our first and main coincidence, which will guide us like a thread through this entire puzzle, through this quest devised by someone, the pair 8, 3. As a result of evenly placing the numbers on the Mobius strip, we ended up with these pairs of numbers. The distance between the numbers in all pairs is equal to half the length of the surface of the Mobius strip. That is, if we measure the length of the strip from any number, the other number in the pair will mark half the surface of the strip. And the first one, in turn, will sort of indicate the entire length of the surface of the Mobius strip. And it is precisely this simple pattern that the author used to highlight the pair 8, 3. If you measure the length of the surface starting from the number 8, half of the surface of the strip will be marked by a figure remarkably similar to half of a Mobius strip, and the entire surface will be marked by a number that closely resembles the whole Mobius strip. No other pair can boast such an appropriate representation. There is a very fitting 0, but opposite it there is a completely unfitting 5. And that's all. That is, it seems quite likely that the author suggests we measure the length of the Mobius strip starting from the number 8, and specifically consider the number 8 as the beginning and the end of the strip. So, the number 8, the beginning and the end. Why do we need this information? What is the author trying to tell us? In my opinion, it seems that the author is suggesting that the symbol representing the beginning and the end would logically be placed exactly where we have the beginning and the end. Moreover, by a fortunate coincidence, something similar to this can be found on the Mobius strip. Here we come to a very interesting point. We have discovered a remarkable, surprising coincidence related to the pair 8, 3, but of course this could just be a coincidence. Moreover, we used a slight adjustment. But this coincidence seems to suggest our next step, move the number 8 to a specific place. I don't think the author meant to move just one number 8, and thereby disrupt the sequence of numbers. I think it would be more logical to assume that the entire sequence of numbers should move along the strip so that the number 8 ends up where we presumably have the beginning and end of the strip. And if this next step, which the author also seems to suggest, leads to something, then it definitely won't look like a random coincidence. It will be like we are correctly understanding the hints left for us by the creator of this quest. That is, if we understood the hint correctly, we should see something else interesting. And it seems we were not mistaken. The pair 6, 9 aligns for us in transparency, or one could say in projection. In general, that's it. These numbers coincide due to the appropriate writing and the suitable place in the numerical sequence. Also because when we place the number 8 in the center of the twist, these numbers ended up exactly on those sections of the Mobius strip where they can only coincide when held up to the light. On both sides of the screw we have these kind of parallel sections that align quite well in projection, and if 6 and 9 are placed on them, they will coincide. On a soft strip, these sections will be longer, but on an elastic one, they will be shorter. But the coincidences will still be enough to attract our attention. However, as I already mentioned, there are similar parallel sections on the other side of the twist, and we, as rational beings, have the right to expect that the author will delight us with something here as well. And once again, we are not mistaken. The pair 5, 2 is symmetrically positioned relative to the pair 6, 9 with respect to the center of the screw. However, the same coincidence as with the pair 6, 9 is not observed, but something can still be noticed. For example, if you slightly alter the writing of the numbers 5 and 2, they will combine to form a number 8 when held up to the light. Yes, I know that to most people this adjustment will seem completely unfounded, but just for you, we will soon deviate slightly from the main thread of our quest to provide absolute, 100% proof of the correctness of our actions. In the meantime, our next, already third coincidence, which we achieved as a result of having the sense to understand the previous hint and place the number 8 in the center of the screw, when the number 8 is at the center of the twist, it can be noticed that the author has also assigned some role to the pair 4, 7 in this puzzle. It also aligns when held up to the light, and it turns out that 4 and 7 can quite effectively represent arrows. And where do you think these arrows are pointing? Well, of course, to the number 8, to our beginning and end. But this pair is harder to notice than the 6-9 pair. For this, the Mobius strip needs to be turned to the correct side, and preferably the twist should be to the right, not to the left. This is the structure we get. 3 pairs of numbers align when the number 8 is at the center of the twist. All these coincidences, one might say, confirm, or one might say independently suggest to us the same position of the numbers relative to the center of the screw, with the number 8 at the center of the screw. That is, as we can see, both of our previous assumptions, the assumption that all numbers should be involved in the puzzle, and the assumption that the number 8 should be moved to the center of the screw, have been perfectly confirmed. But I know that there are still skeptics among you who will say that the writing of many numbers has been altered. But even after that, they do not match closely enough. But if we had at least achieved perfect matches after adjustments, then we could definitely claim that we didn't just make something up, but rather guess the author's intention. Well, I have something to offer to such skeptics. For this, as I promised you earlier, we will briefly deviate from the main branch of our quest. But before that, let's summarize some points. So, what did we achieve by following the author's hints? The main conclusion is that we did the right thing by simply, without any trickery, writing the numbers on the Mobius strip as usual. As a result, we have the strip is divided into 5 parts by pairs of numbers, and the numbers divide the surface of the strip into 10 parts. The number 8 is the beginning and the end of the Mobius strip. The pairs 6, 9, 4, 7, 5, 2 only align correctly when the number 8 is in the proper position on the strip. On the other hand, the coincidence of pairs of flipped digits indicates the correct position of the number 8, and all of this together should suggest our next step. Let's start with the first point. Pairs of numbers divide the Mobius strip into 5 parts. Perhaps there is an interesting way to divide the strip into 5 parts. And to our surprise, we discover that yes, it is possible. And what's even more surprising, it turns out there's only one interesting and beautiful way to divide the strip into 5 parts. That is, in all other cases, it will just be a crumpled, crooked, unattractive strip. And only in one case will it be composed of identical, even, beautiful, non-deformed elements. It turns out that such identical 5 elements can only be equilateral triangles. Only equilateral triangles do not bend or deform when forming a strip from them, maintaining their original shape. A strip made of 5 triangles folds into a small pyramid for us. It also becomes a Mobius strip, a small pyramid. So many associations immediately come to mind. Maybe the puzzle author will tell us something about real pyramids as well. However, our little pyramid can also fold into a triangle. But even here, there are many associations. I remind you, we are trying to understand the structure of the observer here, and now we've come to the pyramid and the triangle. Well, obviously we need to place the numbers somehow. We know that the number 8 should be placed in a spot that can be considered both the beginning and the end of the Mobius strip. By all indications, it is here. Here we have both the physical beginning and end, and the transition from one surface to another. Therefore, the number 8 is here.
But it turned out that the numbers placed on the edges cannot match in principle. Well, that's correct. Who writes like that? Anyway, they usually write it like this or like that. Well, you can also do it upside down. Let's say we've figured out the 8, but how do we write the other numbers? Here we obviously have problems with orientation. There isn't just one option, and it's unclear which one to choose. But we remember our main conclusion. All previous matches appeared because we simply, without any tricks, wrote the numbers on the tape as usual. So maybe here we should just write the numbers as usual. If even now, by following such a simple rule, we come to some interesting result, I will be forced to admit that this puzzle is brilliant. We have 4 options. Unfortunately, however, the matches are only partial and incomplete. In fact, all pairs do not match or correspond anywhere. Yes, but it's not just the 8 that shows the correct position of the numbers on the tape. The pairs of numbers also show the correct position of the 8 with their matches. What if the 8 has another correct position? You will laugh, but that's exactly how it is. It's a surprise. It's something we didn't even dare to hope for. It's something that exceeded all our expectations and brilliantly confirmed all our assumptions. We simply place the numbers from the pairs opposite each other, and on 2 out of 4 tapes, they match when held up to the light. Moreover, we see that with uniform writing, they can match perfectly, with any precision we need. To give you a better view, I specifically made this large tape with numbers drawn on it, as if it were transparent. We got what we wanted. Our adjustment of writing the numbers indeed leads to perfect matches. Evaluate how well the numbers definitely and indeed match, and the pair 6, 9, which has been bothering us for about 500 years, and whose writing we haven't changed at all, and the pair 4, 7, whose writing had to be adjusted for better matches on a simple Mobius tape, also, surprisingly, matches perfectly, and the pair 2, 5, for which we significantly changed the writing and even invented that these numbers should form an 8 when viewed through the light. And here, for some reason, it matches perfectly. That is, it perfectly forms an 8. And the number 8, as it should be, is both the beginning and the end. On the pyramid, the triangle with the 8 came out at the beginning and end of the tape on one side, but here it just comes out on the other side. But there are also arrows, the numbers 4 and 7. On a simple tape, they pointed to the 8. And here they do it even better. They point to the 8 much more clearly and understandably. The matches, as you can see, are much better, more amazing, and more precise than on a regular Mobius tape. They are completely unambiguous and undeniable. The pairs of numbers that initially matched on the Mobius tape, and whose symmetry, especially the pair 4, 7, seem perfectly suited to the tape's twists, surprisingly match best on a tetrahedron. For me personally, this is a completely unexpected, shocking, absolutely brilliant twist in this puzzle, especially if you remember that these matches were achieved thanks to the simplest rule, writing the numbers as usual. Moreover, with this simplest method, we immediately found the only correct arrangement of numbers on the tape. These 4 triangles form a tetrahedron, and only with this arrangement of numbers in these triangles will we have a complete match of all pairs, and not under any other circumstances, so there's no need to look for other options. We hit the bullseye right away. Well, the element with the 8 and the 3 can be placed either to the right or to the left of this remarkable 4. Undoubtedly, such perfect matches indicate that this figure has some relation to solving the puzzle, and consequently, to the structure of the observer. But the thing is, this is not a Mobius strip. At best, it's just a tube or a ring. And let me remind you that at the beginning of this quest, there was a question: why does the Mobius strip keep catching our eye? And in some continuous way, this thing cannot be made from a Mobius strip. The strip needs to be cut, and only then can it be turned into a tetrahedron. In other words, the coincidences are beautiful, and our object apparently has something to do with solving the puzzle. But the fact that it is not a Mobius strip is completely unclear. Therefore,
This branch of the quest does not seem independent and requires further explanation. The tetrahedron itself is magnificent. There is no object more suitable for the role of an element, a cell of space. And what could indeed be perhaps a better observer than space itself? Moreover, we don't just have a tetrahedron, but a tetrahedron with a free element that can change its position, and thereby possibly change the state of a space cell. And this already resembles memory, but if you haven't forgotten yet, we embarked on this quest branch just to confirm that we guessed the writing of the numbers correctly. And I consider this task accomplished. And now we return to our usual simple Mobius strip, to the main thoroughfare on the path to solving our riddle. For the sake of the previous digression to pyramids and tetrahedrons, we ignored the simplest, most obvious clue. If the numbers are opposite each other and match when held up to the light, isn't the author suggesting that they should simply be roughly connected? Now we are aligning 6 and 9 and taping them together. Next we align 5 and 2 and tape them together as well. This results in a little gadget like this. Here are 5 and 2, here are 6 and 9. Now we will match 7 and 4. As you can see, doing this is not easy. It's hard, somewhat unnatural. The numbers don't want to align. Some effort needs to be made. In my opinion, this is very unattractive. Next, we ended up with some kind of tail. On this tail, there is an 8 and a 3, like half of an 8. And we also have other halves of the figure 8, over there in the center. In the center, we have the 0 of the half of the figure 8, the 2 of the half of the figure 8. A 5-pointed star for the puzzle. If everything aligns, in the end, you'll get this kind of quirky shape. But even if you don't aim to connect the numbers exactly, literally, this construction still looks somewhat unnatural to me. No matter how strange it may be, perhaps it already evokes some associations for someone. It bothers me that neither in this solution nor in the previous one did we fully use the hint that the 8 is the beginning and the end of the Mobius strip. In both solutions, the 8 was paired with the 3, and the other numbers were also connected in pairs. Despite this connectedness, we ended up with something interesting. But we can separate them. To see something interesting appears when the beginning and end of the strip is an 8. The numbers can be separated. Thank goodness, the author never gives us a reason to think that we have to deal with some abstract thicknessless strip, like the mathematicians do. Well, if the strip has thickness, then to separate the numbers, it is enough to carefully cut the strip, or more precisely, to layer it. And we will get something like this. On such a strip, the 8 will be separate from the 3, and all other numbers will be separate from each other. And it is on such a strip, and only on such a strip, that the 8 alone without the 3 can be both the beginning and the end. So, when the author hinted that the number 8 is both the beginning and the end, he was suggesting that the strip should be cut, layered, and doubled. Does this mean our previous attempts to find a solution were a mistake? No, of course not. With the cut strip, we can do everything we did with the whole strip. But now we also have some new possibilities. The simplest way is to connect our now freed numbers and reversals. But it turns out there is more than one option. So which one should we choose? Maybe our arrows will give us a hint. In previous versions, they always pointed to the correct solution. I warn you, this solution might seem unconvincing, but the fact is that it fits very well with other solutions. So, let's give it a try. We combined 4 and 7. We have combined 4 and 7. Now this movement suggests itself to us. With this movement, we combine the digits 8 and 3. Now we see that the digits 5 and 2, 6 and 9 are close to coinciding. 9 is kind of close to me, so to coincidence. From the configuration of the strip, we see that the 0, like half of an 8, seems to be directed here, towards the center, where the other half of the 8 and the 8 itself are, like this, and thus brings our flipped digits closer together. 2, 5, 2, 5, 6, 9, 6, 9, 6, 9, 9, 6, 9, 6, 9, 6, 9, 6, 9, 6, 9, 6, 9, 6, 9, 6, 6, 9, 6, 6, 9. Well, the author aims to draw our attention to this object, such a triangular construction. Do you notice the triangularity of this construction? There are no coincidences in the light, but at least for the first step, these remarkable arrows, which have always pointed to the correct solution before, indicated this option to us. And it seems to me that it is precisely to this object that the author wants to draw our attention. It is this object that should tell us something about the structure of some observer. But if you remember, the flipped digits matched best on the tetrahedron. On the tetrahedron, everything is perfect. There is only one problem. The tetrahedron is not a Mobius strip. And the clue that inspired us to investigate this specifically mentioned the Mobius strip. It's also unpleasant that there is no transition from the Mobius strip to the tetrahedron. First, the Mobius strip pyramid needs to be disassembled, and then the tetrahedron can be reassembled from the unfolded strip. This misunderstanding could be explained if there was some transition from the Mobius strip to the tetrahedron and from the tetrahedron to the Mobius strip. And imagine, there is another incredible coincidence indeed. The transition has been found. Our cut double strip can be divided into 10 segments, and the joints of the segments can be marked with digits, and then everything goes as usual. The numbers 6, 9, 2, 5, 4, 7, 8, and 3 are connected again in the same sequence as before, ensuring the continuity of the process. And here we add a 0 as another half of an 8, and now we have a schematic tetrahedron, again with a free element. It resembles an oscillator with the coincidences of digits, and on a paper tetrahedron of the form. But not only. There exists a unique correspondence of a special kind between them. The digits on the vertices are arranged so well that they can be uniquely, without omissions and without repetitions, associated with the imaginary faces of this schematic tetrahedron, and this distribution of digits on the faces will correspond to the distribution on this old tetrahedron of ours. Here we have face 6, 1, and here we also have face 6, 1, face 2, 7, face additionally 2, 7. Here we have approximately a 2, here we have about a 7, face 9, 4, and here is face 9, 4, like 9 and 4. And finally the fourth face, 5, 0, and here 5, 0, and the pair 8, 3. On this tetrahedron made of one-dimensional elements, the pair 8, 3 can be associated with 3 faces. Well, on this tetrahedron made of two-dimensional, so to speak, elements 8, it can also be correlated. With 2 of these faces, this way it can be done, or it can be done this way. Here they are, the 3 structures to which the matches of the inverted digits have led us. Here we have a tetrahedron made of two-dimensional elements, a tetrahedron made of one-dimensional elements. There is a one-to-one correspondence between them. Finally, our little oscillator also has a one-to-one correspondence with the tetrahedron made of one-dimensional elements. Of course, there is a one-to-one correspondence between these objects as well, but it is not as obvious. All these 3 objects are apparently what the author of this puzzle calls the observer, or to put it another way, these objects say something about the structure of a certain observer. I want to remind you that we arrived at these objects through a sequence of reasonable, logical, and well-founded actions. First, we noticed the similarity in appearance between the digit 8 and the Mobius strip. We assumed that this is not a random coincidence, but a hint at the connection between the digit 8 and the Mobius strip. Then we hypothesized that not only the digit 8, but all other digits are somehow connected to the Mobius strip, and placed them on the strip. As a result, we immediately obtained our first match with the pair 8 and 3. We interpreted this coincidence as advice to consider the digit 8 as the beginning and end of the Mobius strip, as well as a suggestion to move the 8 to a place similar to the beginning and end of the strip. We did so, and obtained 3 more coincidences. After exploring some of the most obvious and not so obvious options, we discovered something interesting. And then we returned to our main clue, that the digit 8, specifically the digit 8, is the beginning and the end of the Mobius strip. As a result, we obtained a version of the Mobius strip where the digit 8 was both the beginning and the end. Next, using the 4-7 pair, we obtained the final configuration of the Mobius strip. And at the conclusion of our quest, we devised a transition from the tetrahedron made of two-dimensional elements to our continuous strip. In doing so, we arrived at 3 possible solutions to our puzzle. I remind you, we were trying to find the structure of a certain observer, presumably encrypted by the combination of digits and the Mobius strip. The hope that we didn't spend our time completely uselessly is instilled by the fact that modern real physicists also love various strips, rings, two-dimensional and one-dimensional objects, and they really love triangles and tetrahedrons, and it is not difficult to see some similarity with our objects here. But, I repeat, only specialists can see or not see the physical background of these objects. However, there is an undeniable, irrefutable, and final result of our investigation. We have come to believe that the digits, the very digits we use every day, were invented by someone specifically for this puzzle and implanted into our consciousness, our society, and our daily life. Moreover, the correct writing has been maintained and protected from changes for centuries. But who are the guardians of the digits and this puzzle? I have a simplified version for the not-so-discerning public. Masons, Illuminati, and all that. But I personally prefer the classics. A disembodied world, an otherworldly realm, the Lord God, guardian angels, demiurges, demons, devils. I don't know exactly who had a hand in this puzzle. But to me, it is evidence of the existence of another world and its involvement in the affairs of our lives.